Hello and welcome to CSIT 165, R programming. In this module, Module 8, we're going to be going over advanced data structures like data frames. In order to understand data frames and to understand and have a mastery of how to use data frames, we need to do a few things. For this week, we're going to be doing some reading. For the first set of reading, we're going to be going through Programming Skills for Data Science, Chapters 10. As well, we'll also be reading R for Everyone, Chapters 5, 14.1 through 14.2.1. For this week, we're also going to have a graded discussion 8. This week, we will have Module 8 exercises that will be exploring data frames so that you can learn to use them, make them, subset them, and essentially understand the basics of data science and get your data into tabular format and learn how to explore that data in that format. This week also we will be having the group project assigned. The group project is the first group project that we've had in this class. The group project is for you to be collaborating with one of your fellow students using GitHub to analyze CSV data that is found online with details explained inside of the project. For the group project, which will be due on April 5th, that's on Sunday at 11:59 p.m., you're to work with one or more project or students on this project. The students will be assigned to you if you do not pick them, which leads to the team contract. The team contract is worth 5% of the group project, and for the team contract, all you're to do is to nominate or elect somebody that you would like to be paired up with. If both students elect or they nominate to be paired with each other, then they will be grouped on this project. If they're not grouped with each other, then they will be assigned with another student who's also in a similar position, or a student that's in a similar position and also has a similar grade in the class. For students who do not participate in this, they will miss out on 5% of the group project, as well as the fact that they will be automatically paired by myself with the student that is closest in total grade percentage as they are up until this point. So that's for the team contract, which will be due this week. For the group project, we'll also have a team synopsis. This will be due on April 5th, Sunday, at 11:59 p.m., alongside of the group project itself. And for this, it's essentially a representation of how you think each member inside of your group participated within the project. And so for this exercise, you'll be allocated $5,000 or of some pseudo money that you can use to allocate towards yourself or your other project members based on how you feel each other did on the project. Please take it very seriously. If you do say that you did all of the work and you were being sarcastic about that, I will be assuming that you did do all of the work. And I will be contacting both of you to find out what exactly did happen and to kind of corroborate your statements when making my grades. So let's go into the team project a little bit more. As far as the team project, which again is due Sunday, April 5th at 11:59 p.m., we have the rubric here, which shows that the team project is worth 5% of your grade. So the group project is worth 100 points. The team contract is worth 5 points. The team synopsis, whereas you are allocating that imaginary $5,000 for the project, is worth 5 points. Your write-up is worth 20 points, and the solution or the way that you solved the necessary things that the group project asked for is worth 70 points. So for the instructions, please read everything very carefully. You guys are to submit a team contract that's due on Wednesday, March 18th by 11:59 p.m. This contract will be used to group you and will be done so as explained earlier in this video. Um, the project requires that students use GitHub for project control and collaborating with others. Collaborating with GitHub is explained in Programming Skills for Data Science, chapters 20. Chapter 3 also goes over GitHub, but not necessarily the collaborative aspect of GitHub and how to do that, both from a centralized or from a forked workflow. So for this project, um, you're to be pulling data from GitHub as well as working and collaborating on the project by submitting changes to documents, to the R Markdown documents, changes to data that you maybe perhaps have downloaded for the team project. All that information will be stored in GitHub, and that's how you'll be collaborating with your partner using efficient GitHub messages. So as far as the documentation for the project is concerned, I'll have a recommended layout found in the GitHub repository, CSIT 165, under the folder Project 1. The template for the recommended layout is named template.rmd. It's not necessary to use this template, but it's highly recommended to partition your document by questions the way that the template does. And when I say that, it means sort of how this is presented here, how we have, and I'm not expecting an active table of contents or anything like that. This isn't actually possible as a PDF format. But what I am expecting is for proper use of headers. So using proper use of headers for segmenting your project document when going over the different deliverables that the project is asking for. Using appropriate responses. So all the responses should be completed outside of the code chunks, meaning the responses should be done as plain text. So if there's a qualitative question that requires that you write a free response type of question, write the answer to that free response question outside of the code chunk. So that it's easier and it's more professional for viewing. The response length for these types of responses should be at least 3 sentences. Although they should be at least 3 sentences, they will be graded on how meaningful they are, as well as how much they are able to independently contribute to the question prompt. And with that last statement, that means that if the question prompt asks you to identify why something was a certain way, do not explain in 3 sentences just using different wording, but essentially saying the exact same thing as to what happened. So please don't just fill to meet the 3-sentence minimum. As far as the documentation, the source code for all the source code is required in the document, and comment lines should be used with the source code. The comment lines should not be used to answer the questions or the deliverables that the project is asking for, but instead they should be used to explain the logic of the code that you are using to show this. So I will be grading on how well your comment lines are used to describe the nature of what you're doing in your code. For reference of what comment lines are sufficient or good to use in your code, please refer to the comment lines that are used in Programming Skills for Data Science. Those comment lines are very good at describing exactly what the programmer is using as far as logic is concerned. All the code output inside of the project or inside of your code chunks are to be shown. So just as all of the source code is to be shown, I also want the code output to also be shown. So that means that if you do not want certain variables outputs to be shown, please do not have them types so that their values will be returned unless if those values actually contribute to the question stem. So as far as what are we going to do on this project? What we're going to do on this project is we're going to be analyzing 2019 novel coronavirus data that is accumulated and operated by the Johns Hopkins University Center for Systems Science and Engineering. This data includes daily time series CSV summary tables, including confirmations, recoveries, and deaths. And so what that means is that we're going to have downloading 3 data sets from this link that is shown through this hyperlink. This HTML web page is available on Canvas. So we will be downloading 3 data sets, CSV data sets from this link, and those 3 data sets will be confirmations, recoveries, and deaths. It'll have the date and the number, as well as the latitude and longitude for the area that those confirmations, recoveries, and deaths occurred. The latitude and longitude will also be accompanied with the country name or the province and area as well. The data fields are stored in this type of format where we have the month, this slant, day, and then year. Now, as far as the project, for the details, the background, the World Health Organization, or WHO, has recently employed a new data science initiative, CSIT 165, that uses data science to characterize pandemic diseases. CSIT 165 disseminates data-driven analysis to global decision makers. CSIT 165 is a conglomerate comprised of 2 fabricated entities, the Global Health Union, or GHU, and Private Diagnostic Laboratories, or PDL. You and your partner's role is to play a data science from one of these 2 entities. Your role is assigned when you receive your partner's confirmation email on Wednesday, March 18th. Now, as far as getting started, in order to get the data for this project, I recommend using the following options. If you have a Windows machine, please use this option at your terminal. You're to use the wget function in order to pull the file that's found at this HTTPS address into whatever directory you're calling this function in. The equivalent function to use on a Mac would be to use curl with this flag, this function flag, as the dash capital O. What the dash capital O means is to save, essentially do what wget does, but it saves it to the current directory that you're found in, except that it actually appends the file name to be whatever is, and the last to be whatever the file name is of whatever you downloaded. So it partitions this as a character by these dash segments, and then takes the last element in that list as an output name. For this, depending on which group you're in, if you're in the Global Health Union or the Private Diagnostic, you're to download your data sets using these functions explained earlier in order to contribute and collaborate on the project. So if you are in one part of the group, then you are to download and upload recovered and deaths into your GitHub for the project. And if you're in another group, then you're to download and upload confirmed into the project. One person is not allowed to upload or to download and upload all 3 data sets. One person needs to download and upload 2 data sets. Another person needs to download and upload another data set in order to get a full grade on this project for collaboration. As far as the project objectives are required to collaborate to produce a document that addresses multifaceted objectives. Please write your code such that knitting your document reflects the most current analysis of COVID-19. i.e., it will automatically answer the following objectives using the most recent data set. What that means is that it would be ideal if when you were writing your R Markdown file that you made it so that you would actually pull the data sets as you knit your document so that whatever your analysis is done on the most recent date available from that data set. And what that means to do is to include a code chunk that would have these types of commands, wget or curl inside of your project. So for the first objective, and this project will have 4 objectives. The first objective is to determine where COVID-19 originated from. In order to do this, we want to predict where the origin started based on the number of cases on the first day recorded for confirmation, recovery, and deaths. For this question, why do you believe this area to be the origin? Show that this is the origin using a conditional statement if possible. For this objective, what we want to do is we want to use these data sets in order to predict where COVID-19 began. What this question is asking is that we take the date, the first date that's recorded within these data sets, and we find which area has the highest number of cases. Whichever area has the highest number of cases, we will take that area for confirmed, recovered, and death. If that area that is the same for all 3 of those examples, then we can say that that area is most likely the origination point for COVID-19. So the conditional statement to suggest this origin can be used by showing that the confirmation, recovery, and deaths, or the country with the largest confirmations, recoveries, and deaths on the first day of recovery are the same. For objective 2, where is the most recent area to have a confirmed case? If appropriate, please list all areas that have had a first confirmed case if they occurred on the same day. For this objective, what we want to do is we want to find, out of all the countries, which ones have had the most recent confirmed case. That is, whatever day you run and you knit this or your R Markdown file, whatever date is on there, this R Markdown file should determine which country from the most recent data set available at that time has had a most recent confirmed recovery or death. In order to do this, we want to take the difference between the last date and the second last date, and we want to find the countries that are greater than 0 difference between those columns. As well, we also want to make sure that the second to last date column had 0 confirmed or 0 recovered or 0 deaths. Whichever countries had deaths or confirmations or recoveries the last date, but not the second to last date, are considered new confirmed cases. For objective 3, how far away is the most recent cases from where the first documented cases occurred? Please provide answers in terms of miles. In order to do this, we want to use the information given to us in the data frame. We have information that would allow us to calculate the miles as the GPS coordinates as latitude and longitude. Many people may not be familiar with how to use latitude and longitude in order to calculate miles. I wasn't familiar with the concept either. However, the solution is very easy to use based on the data that we have. We can use a package called geosphere to calculate distance between 2 coordinates in meters using the function distm. Remember, by saying geosphere : distm, we're saying to use the function distm of the package geosphere. You will need to convert the value returned by distm from meters to miles. This conversion is simple and can be found online. Please use a table or print a statement to describe what province, state, and country region first confirmed cases occurred, as well as the distance in miles away from the origin. Please print the following. Recent city is distance in miles away from origin city, origin country. If more than one recent city exists, print the statement above for each city in order of distance from origin. For objective 4, CSIT 165 the group that you and your partner are part of in this mock experiment characterize diseases using different metrics. Risk score, and burden score are particularly important for characterizing disease impact. Risk score is calculated as the ratio of deaths to recoveries. That is, the risk is equal to the sum of the deaths and the sum of recoveries for that country or area. Areas are characterized as being especially vulnerable to loss if they have higher risk scores. Death burden score is calculated as a product of confirmed cases multiplied by the risk score for that country or that area. That is, the burden is equal to the sum of the confirmed cases for the areas that comprise of a country, multiply the risk by the risk score for that country. Areas with high burden scores are expected to have large losses. Question 4.1. Which area of the world currently has the lowest risk score? Which area of the world currently has the highest risk score? How do risk scores in these areas compare to global risk score? How do most risky and least risky areas of the world compare in terms of death burden? Do these values seem reasonable? What are some possible causes for this discrepancy? Why might it be helpful to calculate metrics like risk scores or burden scores for different areas of the world, and what would its limitations be? That is, what assumptions does it make, and important variables might be left out. For question 4.2, you are asked to make 3 tables with top 5 countries that have the most COVID-19 related confirmations, recoveries, and deaths. Make sure to include all the counts for that country, not just the counts for one area in that country. To do this, we need to do the sum of all the values for each country, create new data frames from these values, and use the package cable to convert those data frames into tables. Hint: packages like dplyr make group operations easy, but they are not necessary, though we will be relying on those packages in the future because of their ease of use. Without these packages, it is possible to sum each country's counts by subsetting the data frame using a list of countries available in the dataset. Use a for loop to iterate through the data frame using the list of countries. For each country, calculate the count sum and assign this value to a list. For this project, after doing these project objectives, we're also to use a Git log. To receive full credit for the project solution, please print Git log at the end of the document in its own self-titled section. To do this, create a bash code chunk similar to R code chunk, that is, bash instead of R. Copy the code below and paste it into your code chunk to print a custom Git log displaying subject, author date, and body of each commit made to that repository. So you can see that using this function command here, that it will print the subject, the author, the date that it was made, and the body. You can also see here that I may not have always done appropriate subject names when I've made my commitments, so, and that's not recommended. Sometimes I'll use something called WIP, and that means work in progress. That's also not recommended. It's better to use appropriate git commit comments and in subject lines when making and pushing and pulling documentation. Now in this module, we're going to be using data frames. In order to use data frames, or to explore a little bit about data frames, we'll use an example library from dplyr. So let's load that library. Inside of dplyr, they have a cool data set called Star Wars. And Star Wars contains a list of information on every character that's found inside of Star Wars related to where it's filmed, or the films that each character was in, their height, what films they were in, their weight, their names, where they're from, etc. So Star Wars is a data frame. In order to view data frames, we can just type Star Wars or that data frame, and it'll print out a list of that data frame. The printed version default by just returning that value isn't very good, however. In order to view it in a more coherent fashion, we can use other functions in order to do that, such as head, which will print the very beginning of the data frame, or tail, which will print the end. This still isn't necessarily very explorable or intuitive. A better way of viewing a data frame for data analysis is by using the view function, using capital V. Here we can see that we have a data frame with the name of Star Wars characters like Luke Skywalker, R2-D2, or Darth Vader, their height, mass, hair color, skin color, eye color, birth year, gender, homeworld, species, the films they were in, the vehicles they were in, and the starships that they flew. This is a very large data table. You can see that this is showing 1 to 13 of 87 entries with 13 possible columns. And what that means is that there's 87 rows with 13 columns. We can also see that by using the functions nRow and nColumn. nRow with our data frame will show how many rows it has, and nCol with our data frame will show how many columns it has. We can also use functions to discover what the names of each of those columns are, using functions like names. This shows that we have 13 names where we have name, height, mass, etc. up until starships. So what are data frames exactly? We've been exploring this and we've been seeing its structure. It seems like it's very similar to Microsoft Excel data table in that we have specified columns and we have specified rows. And it seems like each of the rows are associated with each other, and the columns or the different elements inside of that row are associated with different unique elements or aspects to whatever attribute that belongs to. So we can see that, but what are data frames exactly as far as an R perspective? Well, they're actually lists. They are lists. Data frames are the exact same thing as lists, however, they have special confinements to them. And those confinements are that each element in this list, which is a data frames are special lists, so each element in a data frame in this list is a vector that has an equal length. So all of the elements inside of a data frame are vectors that have the same length. Now, remembering from earlier statements, a vector or an atomic vector is a variable container storing any number of different elements that are of the same data type. So here we can see name, and we see that this is a character data type. Luke Skywalker is a character. C-3PO is a character. Height is going to be a numeric. Hair is going to be a character, numeric, character, and then character vector. So all of the elements inside of all the columns are the same type inside of data frames, and all of the elements in all of the columns have the same amount, or all of the columns have the same amount of elements with each other. So the length of name is 87. The length of height is also 87. For areas where we do not have data corresponding to that character, such as C-3PO, we have an NA value. And we can see that we have NA values for a number of different characters depending on what data is available to them. This reflects data that we would find in real life, whereas not all the values for data sets are always given to us. Sometimes we need to learn how to work around those. Inside of the project, we'll explore some of those different methods of doing that. So, as far as data frames are concerned, with being similar to lists, they are very similar to lists. They are also the primary two-dimensional data storage type used in R. The elements inside of a data frame correspond in the same row, and each row may have a different data type. In order to create data frames, we can use the data.frame function. And so in order to do this, let's let's first learn how to subset our data frame Star Wars into different variables and then turn those variables into a new data frame by itself. As far as subsetting Star Wars, let's first make a new variable called names. And we'll make it so that that is in Star Wars, but will be the list inside of Star Wars. So when we do Star Wars, we can subset the names using the $sign and name. And we can see that that will print out a list of all the different names that are found inside of this data frame in the order that they're used inside of this data frame. Now, if we also want to do something with their mass, we can do that the same way. We can also do mass equals Star Wars $sign mass, or we can subset it using the bracket notation, meaning Star Wars, comma, and then we can subset it by name in the column section. Subsetting it like this with the bracket notation, we subset first the row and then the column. When we do that, we can see that we have the elements listed as far as that's concerned with mass. The class for mass is a numeric vector. So we were able to subset that based on that. If we specified 2 column names here, then we would be returned not a list or a vector containing the element that corresponds to that column, but we would be returned a data frame itself. Now let's say that we also wanted to subset one more thing, and we wanted to do homeworld. That's interesting. Or species. Let's do species. So we'll say species equals Star Wars. Well, first we can, to explore a new way of subsetting data frames, we can also subset them using classical index notation that's found inside of lists. And so looking at the names of Star Wars, we can see that to find out where species occurs. We can see that species occurs here, but we can also do species to see that it is in Star Wars, and then to look at the index, we can see that it's at index 10. And so when we click on species, we can see that it looks like this. Well, this is not what we expected. We expected to see something like this, a character vector with all the different species names on there. However, instead, we actually get what looks like to be another data frame. We can test to see what this is by testing it with class. It is a data frame. What did we go wrong? When we specify for species, we use a single bracket notation. If you recall, when subsetting for lists, using a single bracket notation will return the element of that list specified by the number as a list itself. So when we use this for data frames, it also subsets it and returns it as a data frame. When we treat lists and we use a double bracket, however, it returns it as whatever atomic type that atomic vector is upon return. So we can see that when we do species, and then when we try species, we return a character vector. And the difference is using double brackets instead of single brackets. Now that we have this list of names, so we have names, we have species, and we also have Oh, I already forgot what the next one. Oh, we also have mass. We can create a new data frame using the data frame function. New data frame equals data frame, where we have species mass and names. When we view new data frame, you can see that we have the species, the mass, and the name. So when you're creating your data frame, use the data frame function and specify with your arguments species or the name of your column or of your element in that data frame as a character vector. So I named it with as a character vector using quotation marks, species, and then I subset what data or what vector or what vector you want to use to fill in that column. I want to use the species data that we subset using the different methods shown. I also did the same thing for mass and for name. When we do name, it's interesting the way that we called it because we can see that if we call on new data frame name, we can see that we have this output, and it shows that we have 87 levels. By showing that we have 87 levels, that means that we have created this data frame with these, the name and also the species, most likely, as levels or as factors instead of as character vectors. In order to create this without these as character vectors, we can do strings as factors equals false. Equals false. Now when we do this, we can see that we have a character vector. Now the problem with not specifying this as false is that we can't really use this data in the same way that we would necessarily, maybe most likely want to. If we wanted to do any type of string manipulation using gsub or grep to find keywords inside of certain column names so that we can specify or subset data frames with columns that contain certain keywords or frames or something to that degree, then we would want to be able to have the elements in that column be a character vector. So, for instance, if we were to use the function toUpper on new data frame name, it does work, however, but it does an excess conversion to a character vector because toUpper only works with character vectors and it doesn't work with factors, and so it does an implicit conversion. As far as data frames are concerned, being able to manipulate them is very easy if you consider them as lists. They are special lists, however, in that they do have different syntax in being able to call on them. The syntax to call and subset data frames that is unique to them is the bracket notation with the row and column specified. That about wraps up data frames. If you have any questions with data frames, please feel free to email me or Zoom me. Thank you.